Question number 8. In the figure below, triangle ABC is similar to triangle DEF. What is the length of the side DF? So we have to find the length of the side which is DF in the blue triangle. We have 5 choices and we have to pick one of them. Before we discuss this question, let us discuss triples, Pythagorean triples, which is this one. A set of 3 integers that satisfy the Pythagorean theorem is called the Pythagorean triples. One example is 3, 4, 5, because if you square 5 and that is equal to 3 square plus 4 square. So when we check it, let me write it and show you here. So if it is a triple and I said 3, 4, 5 is a Pythagorean triples, which means a square plus b square is equal to c square. Now in here, 5 being the longest side, it has to be c, and 3 and 4 can be a and this can be b, but the 5 has to be as the hypotenuse, which is the longest side. So in here I'm going to say whether 3, 4, 5 is a triple or not. So I'm going to say 5 square, is this equal to, I'm putting a question mark, is this equal to 3 square plus 4 square? So I'm going to simplify this. This is 9 plus 16. Is this equal to 25? And we say 9 plus 16 is 25, and that is equal to 25. So it confirms that yes, it is true. So 3, 4, 5, these 3 integers satisfy the Pythagorean triple theorem. So it is a 3, 4, 5 is one of the triple. Likewise, we can see there are some other triples, which is 6, 8, 10, 9, 12, 15, 5, 12, 13, and there are many more which I will be discussing in another section of this website under the high school Common Core State Standard under the geometry section. And that section, you can see there is going to be a full explanation of different triples, and it will be, I'm going to show you something in here that is, let me move this out and let me put this here, where we will discuss Common Core State Standard. Under the Common Core State Standard, I'm going to discuss how you can find more of these triples using very special polynomial identity which is given here. But this is not in the preview of this video. So I'm going to go back to my question and we will discuss this in another section which you can see. Let me go back to our question. This is my original question. As you can see here that the given triangle is 3, 4 and it is a right triangle, which means then the hypotenuse has to be 5. Even if you don't know the triples, you can use Pythagorean theorem and you can find the length of the hypotenuse, which is AB, and that is going to be 5 but I always prefer to answer the SAT question. The student should know different triples. It makes it much easier and faster to answer the SAT questions. So now in here this is going to be 5. So now we got the third side or the hypotenuse of the yellow triangle. Now we have to find the length of DF. We can have a ratio because these two triangles are similar as given here. So that means I can set up a ratio and proportion. And so I'm going to say that 5 over 7 is going to be the same as 3. The corresponding parts of the similar triangles are in proportion over DF. So that is the length of these segments. So I can solve this and find the value of DF. So therefore DF is going to be equal to 3 times 7 divided by 5, and which is going to be 21 over 5, and the answer is B. I hope you understand the question and its explanation.